All right, on today's episode of Python Papi, we're back inside our smart contracts project. Let's have a look at what we went over today. Now, yesterday, if you recall, we started the module of the Vyper Moccasin best practices. We actually finished that module, so we're going to do some light reading and then I'm going to run some things for you. So, the first data type we are going to be using is the uint data type. This is used to store positive integers. For us to deploy our contract, we need to compile it. Although we are writing code with words, we are not sending code with words. We are sending the runtime byte code, which is made up of numbers. The byte code is what the EVM understands. The EVM is the Ethereum virtual machine. This is the machine that runs our smart contract. The EVM is a virtual machine that runs on the Ethereum network. It is responsible for executing our smart contract code. The EVM is a decentralized machine that runs on the Ethereum network. So basically, whenever we compile our code, we are converting our code into byte code. We are transforming it into a code the language understands on the EVM. Now, with that being said, I'm going to come over here and run some things for you. We actually did finish up this module. Let me show really quickly. And I'm not going to read all of this stuff for you. Just to let you know that we did finish it. And I'm going to let you know about the next module we're starting. But let me come over here so I can run this for you. So this is our first line of code here. My favorite number, uint 256. And we're actually going to run that, and we're going to see exactly what we get back. I learned how to compile it, as you can see. This is how we compile it as opposed to using the python.py. We use the Vyper.py. So we're going to use that. We're actually going to compile this first piece of code here and see what we get. So you can see back we get back this uint here, or this value, the 256 bit. So that's what this returns right here. I'm going to comment this out and I'm going to run a second piece for you. So this is the same thing here. We actually going to run the public version of it. Now I know I didn't explain to you what the public version does, but it actually just makes the value of this number here public to us if we were using the Remix IDE, which we're not using, so we're not going to be able to see the value of it anyway. But if we wanted to see the value of this actual number here, we would use this public word first. We would wrap this around the uint 256, and that will make our value public, which is default 0. Whenever we don't designate a value for our uint, it's always going to be default of 0. So let me go ahead and run this version of it and see exactly what we get here. So it's the same thing. We're just going to run it as a public value and see what we get back. And you can see it's a lot longer here. Why is that? So this will produce a longer number when compiled because it is combined with a visibility modifier. It defines a variable that can store a 256-bit unsigned integer value and automatically generates a getter function for it. So that's why this number seems longer, even though they're same, it's the same exact value, the same exact number. This one looks longer because it's actually wrapped inside of a visibility modifier that will allow us to view the value on the Remix IDE. Now that's basically what we went over. We finished up with the best practices, like I said. The next module we're going to start is the functions. So yeah, I'll explain more of that when we actually get into it. And of course, I will keep you posted every step of the way. But for now, it's the Python Poppy. You guys stay Gucci.